channel. So in this video, we'll be solving some of the previous year questions that has appeared in various entrance exams from surface chemistry. So moving on to the first question. So this has appeared in CUCET 2019 and the question says that the absorption of the gas on a metal is governed by the Langmuir isotherm with the equilibrium constant K is 0.4 kilopascal. And calculate the fractional coverage at a pressure of 1 kilopascal. So this we have to use a Langmuir adsorption isotherm and calculate the fractional coverage, which means that they are asking for theta value. Theta value is the one that is unknown. K value is given to be 0.40 and my pressure is given to be 1. Both of them are in the same unit, so it doesn't matter. Now, what equation can I use? So from Langmuir adsorption isotherm, I know that my theta is given by Kp by 1 plus Kp. This is the Langmuir adsorption isotherm equation that I have. I simply have to substitute the value of K and P in the equation to get the value of theta. That is 0.40 into 1 divided by 1 plus 0.40 into 1. This is 0.40 divided by 1.4 and the value would come out to be approximately 0.2. So I can say my theta value, the right answer for this question is option A, which is 0.2. That is the fractional coverage. So moving on to the next question. This is from Pondicherry University entrance examination given in the year 2018, where it's a direct question where they have just asked who the multi-molecular layers are formed in which type of the adsorption. They've given chemisorption, physical adsorption, reversible adsorption, and absorption. So we learned that there are two types of adsorptions, which is chemisorption and physisorption. And chemisorption forms unimolecular layers and it is physical adsorption which forms multimolecular layers. And apart from that, absorption, it is not forming layers, the molecules are penetrating into it. It's a bulk phenomenon, it's not surface phenomenon, it's not forming layers. And reversible adsorption, it's actually a property of physisorption itself. Physical adsorption is reversible, so it's just a property of physical adsorption only. So the multimolecular layers are formed by option B, physical adsorption, or we can say physisorption. So answer B is the right answer here. So the next question is from GATE 2016, where it is told that adsorption of carbon monoxide on charcoal at 273 Kelvin follows Langmuir isotherm. A plot of P by V versus P is linear with a slope of 0.01 and y-intercept is 0.5. The equilibrium constant K for the adsorption is dash. So they've asked for the equilibrium constant K. They've told about a linear plot between P by V and P, where the slope is found to be 0.01 and y-intercept is found to be 0.5. So we have an equation for the Langmuir adsorption isotherm which says that P by V is given by P by V mono plus 1 by K V mono. We have an equation like this in Langmuir isotherm. So I have explained this equation and how this equation came. All that part I've explained in the previous video on surface chemistry. So if you've not watched that video, do check out the link given in the description box. So moving on to the question. So this is the equation we have. Now this equation is of the form. So if you look at this equation is of the form y equal to mx plus c. So this equation that I have is of the form y equal to mx plus c, where my y is p by v and my x is p. So m is the slope and c is the intercept. So it is similar to the details given in the question. So comparing the equation that I have and the details given in the question, I can write the slope to be 1 by v mono. This is from the equation. And the value of that slope is given to be 0.01. Okay. And I also can write about the intercept. Next, I can write about the intercept. Now, talking about the intercept, from the equation, intercept is 1 by K into P mono. Okay. And the value for intercept is given to be 0.5. Okay. Now, in this, what does that mean? 1 by k V mono is 0.5 means instead of 1 by B mono, I can substitute the slope value. This is same like 1 by k V mono means that is same like slope by k equal to 0.5. So implies my slope value, I can substitute it as 0.01 by k equal to 0.5, and upon rearranging my k value would come out to be 0.02. This is the k value that I get, that is 0.01 by 0.5. The value would become 0.05. So for this question the answer is 0.02. This is the right answer for this question. We just have to write the equation. We should be knowing this equation. From the equation, I can find the slope and intercept, substitute the values from the question, and upon rearranging, I can find my k to be 0.02 here. So this question is from BHU 2010 paper. So it's a direct question where they have asked why the PET equation is used for the application of PET equations, and it is in finding out the surface area or to find out the surface charge or concentration of a solution or the ionic diameter. So directly we can say that PET equation or the Bronner-Emmett-Taylor equation is used to predict the surface area, used to determine the surface area, because if we have the V mono value, that is the volume of the adsorbent or the surface for a complete monolayer coverage, that is V mono, if that is known, we can calculate the surface area using the PET equation. So option A is the right answer. It was direct, nothing complicated or no equation as such to be used in this. So the next question is from JAM 2018, where they've told that for the adsorption of a gas on a solid surface, the plot that represents Freundlich isotherm is, and the plots given here, the ABCD, the plots that are given here are between log x by m and log p, where x is the mass of the gas and m is the mass of the adsorbent and p is the pressure. Now 4 different graphs are given here, so we have to find out which of the following graphs would represent the correct Freundlich isotherm. So now what is the Freundlich adsorption isotherm equation that we have? We have the equation to be x by m is equal to k p raised to 1 by n. This is the equation we have. Now let us take log on both sides. So if I take log on both sides, what would happen? This would become log x by m equal to log k plus 1 by n log p. Again, this part, how this log, how it is changing when we take the log, how that p raised to 1 by n becomes 1 by n raised to p and all, I've explained in the previous video. So now this is of the form y equal to mx plus c. This is the form of a straight line having slope to be 1 by n, my y-axis to be log x by m, and my x-axis to be log p, and the intercept is log k. So simply you just have to take the log for Freundlich adsorption isotherm equation, and when I take the log, I get it in the form of a straight line y equal to mx plus c, with y-axis being log x by m and x-axis being log p. It's a positive slope, so the graph would be a straight line which goes upwards. So I can say my graph given here, this is the right graph with this to be the intercept, which is log k, and my slope of the graph is given by 1 by n. So this is the right answer for this question. So next question is from GATE 2015, where it is told that the process given below follows the Langmuir adsorption isotherm, and if theta denotes the surface coverage and p denotes the pressure, then the slope of the plot of 1 by theta versus 1 by root p is dash. So they've asked for a slope of a particular plot between 1 by theta and 1 by root p, and they've given an equation or a process, and it's a Langmuir adsorption isotherm process that's happening. So now we know that for Langmuir adsorption isotherm, the equation of theta, the surface coverage theta, is given by Kp by 1 plus Kp. This is the equation we have. Now this is for the equation when we have monoatomic gases. Now if my gas can undergo association or dissociation, if it is dissociative or associative mechanism, then in such cases my theta equation becomes like theta equal to Kp raised to 1 by n divided by 1 plus Kp Kp raised to 1 by n. This is the equation. That 1 by n part also comes when it is associative or dissociative. Now here, this is the equation that I have because I'm having A2 gas. It is getting dissociated to 2A. So obviously this is dissociative in nature. So I have to consider the second equation. Now considering the second equation, that n value would become equal to 2 because A2 is getting dissociated to 2A. So my n value would become equal to 2. So I can say that my n equal to 2, this is what I can say. And now in the question they have asked for 1 by theta. So I have theta in the equation. So only if I reverse the equation, if I take the reciprocal of the equation, I would get 1 by theta. So the second equation that I have, let me just reverse the equation, take the reciprocal of it. And instead of n, let me also substitute it to be 2. Okay. So I can write it as taking the reciprocal. So 1 by theta would become equal to 1 plus Kp raised to, instead of 1 by n, I'm putting 1 by 2 divided by 1 Kp raised to 1 by 2. I'm just splitting the denominator between the two numerator values. So this would become as 1 by Kp raised to half plus Kp raised to half by Kp raised to half would become 1. So I got my equation as 1 by theta is 1 by root k into root p plus 1. So this is of the form y equal to mx plus c, where my y is 1 by theta and my x is 1 by root p, intercept c is 1 and my slope is 1 by root k or 1 by k raised to half. This is the equation that I get. From this, I just have to take the reciprocal of normal Langmuir equation, and upon taking the reciprocal, I can find that my equation is in the form of y equal to mx plus c, where m or my slope is 1 by k raised to half or 1 by root k. So my option D is the right answer in this question. So is this clear? So let's move on to the next question. So this is from HCU 2016 paper. So they told that the absorption of a gas is described with K equal to 0.777 kilopascal at 25 degrees Celsius pressure. At 25 degrees Celsius, the pressure at which the surface coverage becomes 0.2 S. So it's a Langmuir isotherm. They've given a K equilibrium value, and they have to also given the surface coverage value, theta value is also given, and they are asked for the pressure. So K is given to be 0.777 and my theta is given to be 0.2. They've asked for the pressure. So in Langmuir isotherm, we have the equation theta is Kp by 1 plus Kp. Now also I can rearrange, or if I rearrange this equation, I can get it in another form like Kp is theta by 1 minus theta. This is another equation that I can have. So now if I have to just substitute the values that are given from the question and this equation. So in the second equation, so let me use the second equation, and that's an easier one to calculate P. So it's derived from the first equation itself. I just have to rearrange the first equation and then I would get it in form of Kp. So I just have to substitute the values. So if I substitute the values, K is 0.777 into P is not known. That's what we have to find. Theta is 0.2 and divided by 1 minus 0.2. Now that is 0.2 by 0.8. Now 0.2 by 0.8 is 1 by 4. That is 0.25. So I can say that my P equal to 0.25 by 0.777 and the value comes out to be 0.32. So my option B that's given here is the correct answer. It comes out to be 0.32 kilopascal. Just by substituting in this equation, we can find out the value of pressure to be 0.32 kilopascal. So we come to the last question of this video. It's from GATE 2018. The question says that for low partial pressure of ozone, the absorption of ozone on graphite surface is fully dissociative in nature and follows Langmuir isotherm. Under these conditions, if the dependence of the surface coverage of graphite on partial pressure of ozone is given by theta is proportional to PO3 raised to x, the value of x is, and answer has to be rounded off to 2 decimal places. So the question looks quite big, but no, it's very simple question, very direct question in fact. So looking at the question, seeing that it is quite big, don't leave the question unattempted. So it's very simple, so just give it a try. So there are three keywords that we should be noting in this question. So one is it's a fully dissociative. It's fully dissociative. That's one thing to be noted. Next thing is it is Langmuir isotherm. That is another point to be noted. And the last thing is they've told that theta is proportional to p raised to x. These are the three keywords that are to be noted in this question. And for Langmuir isotherm, we have the equation as theta is equal to kp raised to 1 by n. So we have the equation for Langmuir adsorption isotherm where theta is related to the pressure as kp raised to 1 by n. And now that is given in the second in the question also. Theta is found to be proportional to p raised to x, and from our equation also I can find that x is 1 by n. So if you compare the question what is given and my equation that I have for Langmuir isotherm, I can find that my theta is p raised to 1 by n is proportional to p raised to 1 by n, which means that my x that is given in the question is equal to 1 by n. Comparing the question and the equation that we have, I can find that the x asked in the question is the 1 by n in my equation. And how do I find this 1 by n? It is told that ozone is fully dissociative. So generally we have like ozone, if we have, it will dissociate to O2 plus O with nascent oxygen. This is how the splitting occurs for ozone general splitting. But here it is told that ozone is fully dissociative. If it is fully dissociative, it would mean that ozone would split into O plus O plus O. So it's splitting into 3 oxygen atoms. It does not split into O2 and O because it is fully dissociative. It will split into 3 oxygen atoms, and instead of N, I can substitute my value here. Instead of N, I can substitute it to be 3. So 1 by 3, and this would come out to be 0.3333, like that it goes. And to round off to 2 decimal places. So to round off, I first consider the first 2 places. So how you can round off answers also, I've given a video. You can check my channel for the video. So this has to be rounded off to 2 decimal places. So I consider the first 2 decimal places. I keep it fixed. Now I look at the third decimal place. If the third decimal place is greater than or equal to 5, then I have to increase this first 2 digits by 1. That is 30. If my third decimal place was 5 or greater than 5, then this 33 would become 34. 0.33 would become 0.34. But in this case, it is less than 5. So 0.33 would remain as 0.33 itself. So my answer is 0.33. So it should be 0.33. This is the answer. So this is how you do this equation. It was very simple. All the questions from this surface chemistry portion or based on adsorption are very simple direct questions, especially when you do this BSc level questions. But when you come to NET exam and other M.Sc level questions, we get little more higher level questions. But right now at your level, all BSc questions, all that comes in the previous year questions are very direct formula applications, nothing twisted or complicated. So that's it for today. Thank you so much.